We've actually got two problems in one here. It says the following reaction is used to form lead-2 iodide crystals. Boom, your reaction is written for you already and it's already balanced. Two questions are, what mass of lead-2 iodide could be formed from 1.0 times 10 to the 3 grams of lead-2 acetate? And question number 4, how many iodide ions would be in the sample? All right, so let's tackle this one question at a time. We're looking for the mass of lead-2 iodide that could be formed from 1.0 times 10 to the 3 grams of lead-2 acetate. Again, you're always going to start with the amount that you're given in the problem. In this case, it's the 1.0 times 10 to the 3 grams of lead-2 acetate. From there, again, the very first thing we want to do, as has happened in the previous examples, is go to number of moles. C2H3O2. For number of moles of lead-2 acetate, we then want to go to moles of what we're looking for. Which is the lead-2 iodide. And then from there, we want to go to moles of lead-2 iodide, 2 grams of lead-2 iodide. Now let me shrink this down a little bit. Okay, as we think about the relationships that exist between moles and grams, again, we're going to the periodic table. I'm going to speed things up for you here. We've got 325.288 grams for every 1 mole of lead-2 acetate. And again, that comes from the periodic table. Make sure you're able to figure that mass out on your own. Mole to mole, that relationship comes from the balanced chemical equation. We're comparing lead-2 acetate to lead-2 iodide. It's a 1-to-1 relationship there. And then again, we've got another mole to gram relationship coming from the periodic table. We get 461.02 grams of lead-2 iodide for every mole of lead-2 iodide. Now, when we solve this, we've only got 2 sig figs in our initial measurement, so our final measurement should also have 2 sig figs. And when you work this through in your calculator, you should get 1.4 times 10 to the 3 grams of lead-2 iodide. Again, let's get crazy with the estimation here. This is going to be 1,000 grams. I'm just going to write that out to help us visualize for those of us who struggle with scientific notation, like myself. If we've got 1,000 grams, that means we've got roughly, again, super rough here, about 3 moles of the lead-2 acetate. And because the relationship between the lead-2 acetate and the lead-2 iodide is 1-to-1, we also have about 3 moles of the lead-2 iodide. And then when you're getting to your mass in grams, I'm just going to estimate 500, which means we're going to have about 1,500 grams of the lead-2 iodide. And again, as you look, this is pretty close to 1,500 grams. Just again, be ready to estimate. You have to work through these problems without a calculator on the multiple choice section of your exam. All right, our next question here asks us the number of iodide ions that would be in the sample. Now, I'm sure many of you mathematical geniuses will be able to figure this out simply by looking at the formula for lead-2 iodide. I'm going to do a quick dimensional analysis here so you can see how it would look sort of all written out. We've got 1.4 times 10 to the 3 grams of lead-2 iodide. I'm going to go back to moles. So we're going to have conversion factor looks something like this. Again, once you've gotten to moles, that's where you're sort of free to go wherever else you might like to go. The moles of lead-2 iodide compared to moles of, in this case, the iodide ions. And then from there, we can go from moles of the actual iodide ions to the actual number of ions. And so as we look at these relationships, for every 1 mole of lead-2 iodide, we've got that 461.02 6.02 grams. Again, that's coming from our periodic table. The relationship between the moles and moles. Here, you don't have to go to the balanced chemical equation. You're just looking at the formula. For every one of these PbI2s, there are 2 moles of iodide ions. And then to get the actual number of ions, you have to go back to Avogadro's number. So 6.02 times 10 to the 23 ions. And so when you solve this using your calculator or your brain, you're going to get 3.7 times 10 to the 24 ions of iodide. Again, think about estimation. We said this roughly 1,400 grams of lead-2 iodide would be approximately 3 moles of lead-2 iodide, which means that we would make 6 moles of iodide ions. And 6 times 6 is 36 times 10 to the 23. And if we move our decimal point over 1, we get 3.6 times 10 to the 24, which is, again, roughly the answer that we determined using our calculator. Again, I can't emphasize enough, it's really important that you're able to estimate these values so you can do it on the multiple choice section of your test in which you're not provided a calculator. Woo! All right, people, we are getting close. Let's take a quick look at question number 5 here.